All right. And so let's look, that's command injection, where you can inject command line bash commands. And the more common problem people see is SQL injection. And the thing about SQL is it works the same way, but you do have to inject code in this language called SQL, which a lot of people are unfamiliar with. So here's something that you would not let a normal user have, but something your administrator has, a box where they can execute arbitrary queries. So they can do things like show databases. SQL is where you store databases, and each database contains tables. This database, there are two databases on this server. One named information schema, which is automatically generated by MySQL and filled automatically with content that always has the same name, which is important for the attacker. And then there's one created by the company called widgets, which will include company data. So if you show tables, you'll see the tables in the database. And it's only going to show you the tables in the current database, which is widgets. So that only has one table named employees. All right. And if you wanted to see the data from employees, you could select star from employees if you had the ability to write an arbitrary query. And then you'd see everything in the employees table, which is a series of ID numbers, names, and social security numbers. All right. Now you can learn to select things. You can select just a number. You don't need to select something from a database. You can just select a constant value and it'll return that value like an echo command. And you can select, you can concatenate strings together, and you can do substrings, which we'll use later. And you can select certain fields, like just the ID from the employees. So if I do this one, it'll give me all the IDs. But it doesn't tell me anything else. I could give it a condition like where name equals Bill Gates. And then it'll give me only the ID for that one user. And this is essentially what is used to fetch the data for you to see your own profile on a service like Twitter or Facebook. It's got a data with, it's got everybody's information, and it queries for your information to show it on your page. So that's the basic thing here. Now, for an attacker's point of view, once you gain the ability to inject queries, which is a little bit tricky, then the place you normally start is down here. You select information from information schema tables, because remember, the information schema database is always automatically created, and there's a table in there called tables. So if you could do a select star, which you usually cannot, you might do this, and then you get everything about all the tables, many, many things. But if you can only get one column, which is more often the issue, then you would choose one fact, like perhaps the table names from information schema tables. And now you get a list of all the tables in a database, and you see all these automatically generated tables. And way down at the bottom is the one created for this company, which is using lowercase. All the automatically generated ones are in uppercase. And you can get all the columns too from information schema columns, which are all the fields in the tables. And you'll see there are many, many columns automatically generated in capital letters, and way at the bottom are the columns actually in the user database, which the employees table, ID, name, and social security number. So this gives you some idea how queries work, and there's a couple of flags to find here using the queries in this list. And then you can do SQL injection. You would never let an end user have access to this directly. Only your database administrator should have that kind of power. But your end user typically has access to something like this, where they can put in their name and then search for that user. So if I search for Bill Gates, well, it's not letting me copy and paste somehow. Let's see. There we go. All right. So in this case, I print out the query so you can see what it's doing. the developer put in this text, selects name from employees where name equals apostrophe, and the developer put in that apostrophe, and the only part of this I control is the Bill Gates in the middle. So it found Bill Gates, that's fine. If I look for Sam, it has no result because it didn't find Sam. So that's the form working as intended. But if I search for a name with an apostrophe in it, like this one, Tip O'Neill, then I get a SQL syntax error, which is the kiss of death. This means you have a SQL injection vulnerability. And the problem is the developer put in this, and I put in this word to search for. The problem is I was able to insert an apostrophe character, and this is making the same mistake as the ping form, where it creates a line of code, which it then hands off to another program to parse it. In this case, it's PHP creating a line of code and then handing off to SQL, which parses it. And when it parses it, it tries to match this apostrophe from the developer with the other apostrophe, but it allows an apostrophe entered by the user to match it. So what it did was it searched for Tip O for a name, and then it tried to interpret this as a SQL command. And that's not a valid SQL command, so it caused a syntax error. So what it means is if you write a more careful injection, you can execute commands on the server. And here's one that will do it. This is one that will give me every name in the database. Here's a common one. What you do, all the injections are going to include this apostrophe. And now I get all the names, and I was only supposed to get one because I created this condition, name equals Sam or 1 equals 1, and the pound sign is a comment symbol, so it got rid of that extra apostrophe that otherwise would break the syntax. So now I have a compound condition, which is always true. Name equals Sam is always false, 1 equals 1 is always true, the combination is always true, so it gives me every name in the database. So that's powerful. And what's even more powerful is to use the union command, because the union commands let you add two queries together. So now that I've done this, I now don't find Sam, but I do find 1. So what I've done by using this apostrophe union and the pound at the end, I now have the ability to insert a select command of my choice. So I have taken this form where I only get to put in a name, and I've turned it into this form where I can put in any query I want, as long as it only has one column of results. So you can take this select command and substitute any of those in, and now you can pump out data. So you can find social security numbers and passwords and so on. Now the pros don't do it by hand this way so much. They typically use SQL Map, and I've got some challenges here. If you have a Linux box and you install SQL Map, you can practice using SQL Map on a few versions of these databases, which is a good thing to do. But I think probably the most fun part of this, in my opinion, is the blind SQL, doing it by hand. So I'll reset the server as recommended. And so here, if I search for Bill Gates in this form, it tells me I found Bill Gates. So it looks like the previous one. But if I search for, I put in one of my injections that should match everybody, then look what happened. It accepted this apparently. Name equals X, which is probably never true, or A equals A, which is always true. The result is true, but instead of this thing sent back to you coming from the database, it just echoes your query. So I know the injection worked because I found a result, but I don't get to see anything. This is called blind SQL injection. I can execute code, but I cannot see the results. So you have to deduce the results indirectly. So in here, I have X or A equals A. If I change this to B and run it, then I don't get an answer. So now I can ask one true or false question. I can put any expression I want here, and if it's true, I'll get a result. And if it's false, I won't get a result. So now you can gradually pump out data. For trying to link to the database's name, for example, you can take this one. And if the length of the database is equal to 1, it would be true, but it's not true, so I get false. So if I make this greater than 1, then it will be true. And now I get an answer. So in this spirit, you can pump out stuff, and you can actually pump out anything. You can now go into substrings and pump out letters one by one, and you can gradually learn social security numbers and IDs and the length of things. You can gradually pump out anything this way. And of course, it's interesting to do by hand this way to understand the principle, but this is what SQL map does automatically. It will find the vulnerability and do hundreds of queries to pump things out character by character for you. So there's some more challenges to check out if you want to try SQL injection.